Hello, my name is Reed Losberg. I am with Intelligent Controls, and I am going to take you through a brief demo and bit of show and tell on what a Victron and Pylontech system can show you, the information that's available, and just how much data we can get out of a system like this with a fully communicating battery. Now, this first page we're looking at here, this is the Victron VRM, Victron Remote Monitoring Dashboard. This is the first page you'll see when you load up, and since we're specifically looking at Victron and Pylontech communications, the first thing I want to point out is this battery status here. And you'll see this 84% and that it's charging. This is information that's coming directly from the battery. This isn't measured by a shunt. This is battery information passed on by the Pylontech BMS to a Victron Serbo GX. Some really basic information here. This 5,000 watts. This is the charge current that's currently going into the battery. Voltage. This is the current battery voltage, the amount of current that's going in the battery, and the battery temperature. This is a system that's stored outside. This 53 degrees Fahrenheit. It's in a building, but it's not a heated building. Plenty of temperature to maintain charge and discharge, and this is kind of the overall battery bank average. Now, as we're looking at this, I want to point out that over here this says external control. And what this means is that this charge controller, which is a Smart Solar 450-200, a pretty significant charge controller, is responding to some sort of external source. In this case, that external source is the Pylontech Master US5000 BMS is passing information on to the Serbo GX, and via DVCC, Distributed Voltage Current Control, which we'll look at in a minute, it is controlling what exactly is happening out of this charge controller. Now, as the system charges and discharges, what that's going to be doing is changing voltage limits, charge current limits, etc. But this is a pretty good indication that you're working with a system that has sophisticated battery communications. Now, later we're going to look at some of the other stuff on this page, the Advanced tab in particular, but for right now, I want to look at the remote console. And this is going to be identical to what you see on a system if you're looking at a GX device locally as well. This page here, we have a few pages that are available on this new graphic interface from Victron. The brief page is kind of an overall summary of things. I like this page, very quick and easy. You immediately know what's happening with the bulk of the system. But this overview page is going to be a lot more information. And specifically what I want to point out is that any of these devices, if there's a device attached to it, one of these boxes, you can click on it and get more information. So let's do that with the battery. Now this is the Pylontech battery. This is what it named itself. The system recognized it as a Pylontech battery, and this is the information that we have available. Overall summary page, voltage, amperage going in, the wattage of that amperage of voltage, etc. State of charge, state of health, battery temperature, Celsius, of course. Let's go into this first menu, the details menu. This is some pretty critical information for the overall operation of the system. Lowest and highest cell voltages. You'll notice that these cell voltages are within a few thousandths of each other, and oftentimes the furthest you'll see them is going to be a few hundredths difference. This is going to be an early indicator of cell balance issues, battery balance issues, overall bank status. Minimum and maximum cell temperature. These are fairly close. What's likely happening here is this 9-degree cell is probably lower down in the bank. A lot of heat that's generated in the bank storage may be rising, so this battery is probably one of the ones on the top. Maybe this battery is low down and on an external wall. This can be a place to go look if you're getting cell imbalance issues or battery balance issues. Is one of these batteries getting too cold? In this particular bank, there are 8 batteries. All of them are online. None of them are doing anything to block charge or discharge. If a battery is full or if a battery is too cold, you may see one or more of them blocking charge and discharge. Cool thing here is that one of these batteries can block charge or discharge, and the whole system will continue operating. Installed available capacity, pretty basic numbers there. the available capacity will start to change if a cell is offline or blocked and some other reason something has shut down there. Let's look at the alarms page. This one is going to be your most obvious, hey, something's wrong, what's going on? Low, high battery voltage, obviously, battery gets too drained, low battery voltage alarm, high voltage alarm if it's too full and there's a charge current that's running away. High charge current or high discharge current. This would be something that would pop up if you have, more often you'll see this in a small bank or a system that has significant loads. A high discharge current alarm can indicate you have a really big load pulling more than these batteries can provide. Low temperature, high temperature, fairly obvious. Low charge temperature, high charge temperature. These are a note that will come up if, for example, very low temperature, you'll end up having a difficult time charging. So if the battery bank is usually below around 40 degrees Fahrenheit, you might start to see some low charge temperature alarms. The cell imbalance is an indication that either a battery is isolating itself or a cell is failing or some other system like that. Internal failure is not always going to be something catastrophic. Sometimes this indicates that there's a communications issue between batteries. Simplest example being a cable got disconnected for some reason. Either somebody was doing some maintenance on the system, didn't connect the batteries back together, connected them in the wrong order, a mouse chewed through a cable, some other indication like that. It's also a bit of a catch-all. If there is something that the battery is noticing is wrong, but it doesn't have it fully set up to tell the system exactly what that is, it may tell you that there's an internal failure. Now let's go look at the next page. This is the device page. Pretty basic stuff here. You can identify what the product is, how it's connected. This is all pretty standard Victron communications information. You could name this specifically if you wanted to name this, battery bank in external shed. You could put some sort of name on this. The firmware version on any Victron device, this will show up. This is something that's more specifically within the Pylontech batteries and the VRM instance. Now let's look at the parameters. This is the most critical area for understanding what's happening with DVCC. That's Victron's Distributed Voltage Current Control menu. And this tool is the most critical way that Victron is going to take BMS information and make use of it in a Victron system. This charge voltage limit, this will set the maximum charge voltage across the system through DVCC. And this charge voltage limit is set by the battery. This is information coming directly from the battery. This isn't something that was user set. This is the battery saying, I don't want any more than 53.2 volts. Charge current limit and discharge current limit. These are exactly what they sound like. As a battery gets full, you'll see the charge current limit drop. Right now it's wide open. It's in the 80% range. As it approaches 90%, we'll see this in a minute in the advanced tab on VRM. But as it approaches 90%, this charge current limit will start to throttle back as the battery reaches full. The discharge limit, same thing. If you've got a cold battery or a battery that's extremely low voltage and the bank is starting to run out, you may see discharge current limits start to drop. For the most part, the discharge current limit in any system that's fully functioning and maintained above kind of a minimum 5% state of charge, your discharge current limit is likely to remain fairly well wide open. Okay, so that's the overall data that you're going to see. This will be what you can see through Victron on-site or with the remote console. Now, let's look at our advanced tab. This is a very sophisticated tool that we can use for monitoring a system. Now, let me zoom out so you can see this a little bit better. All right. Okay, so this is information coming directly from the battery. This is the last 2 days of information passed by the battery. Up in the upper left, we'll start and you'll see our state of charge drop down to 72% overnight or 70% overnight. And then yesterday morning, started charging again. That was this morning, got down to 71%, and it's currently in the midst of charging. Battery voltage and current. This is the voltage and current that's going into and or out of the battery. You'll see here during the day, this charge current is positive. It's charging, adding to it. Overnight, it is discharging, meaning it is below zero on this point here. This BMS charge and discharge current limits. These are what we were looking at on that page within the remote console. Now, as we went through the day, you'll see here as the battery approaches 90%, this charge current limit begins to drop. Now, this is the battery going from kind of a bulk cycle into more of a top-off absorption cycle. Now, that charge current limit, still a pretty significant charge current limit. That's 160 amps total, which is almost everything that our solar can give it, but is spread across 8 batteries. Now, as the battery bank reaches full, you'll see it gets up, and as soon as it reaches 99%, that current limit drops a little bit more, and at 100%, the charge current limit drops to 0 amps. In the Victron system, if you have a load on this, and say you've got a 1,000-watt load and at least 1,000 watts of solar available, the system will still be using that solar to charge your loads. It's just limiting it so that it makes sure it doesn't overcharge this battery and damage anything. Now, as we drop off throughout the afternoon and we start drifting from charging into discharging, hit 90%, you'll see that charge current limit comes back up. And then as it drops below 90% again, the charge current jumps further all the way up until we're around 85 to 87%. And we have a wide open charge. Next one we're going to look at is the minimum maximum cell temperatures. And we do see a little bit lower of a cell voltage here. Minimum cell temperature, 46 degrees Fahrenheit. And you'll notice the charge-discharge current limit adjusts ever so slightly, likely because of that minimum cell temperature. It didn't want quite as much amperage coming into the system. So very sophisticated, very thorough back and forth. The amount of information and control that the battery has is really impressive. You notice over here our minimum maximum cell voltages. This is an indicator of overall battery bank balance. You'll see that it gets the most out of balance when it's at full. This is perhaps one cell that just takes a little bit more charge voltage than another. But overall, this system is always within a few hundredths. It's a very tightly focused, tight balance on the overall system here. In a lower quality battery, you may notice that these minimum maximum cell voltages are much more divergent. Pylontech is particularly tight, within a few hundredths at any given time. I've seen other batteries that are also communicating, but not as high quality of a battery, and that may be a few tenths, or a couple tenths at least, of difference between the minimum and maximum cell voltage. Battery summary, this is the current status of the battery, so current voltage, current amperage moving into the battery, the amount of charge power going into the battery. Just some quick and easy information here. But yeah, this was a very quick overview of some of the information that you can see within a Victron power system with a fully communicating Pylontech battery bank. We didn't even cover it all in the advanced tab. There are more details that you can see within the custom widgets and within the remote console under the DVCC menu. I hope this was helpful. Let us know if there are any questions that you have about this, and reach out to us at the email provided below. Thank you.